Hey everybody, Freddy here with another video. Welcome to day 4 of the Azure Monitor Cost Optimization series. In this video, we're going to go ahead and focus on transformations. We're going to talk about, first of all, what transformations are, where to find them, and then we're going to go deep into the JSON code where you're going to be able to filter out noisy rows. We're going to talk about how to trim the payload size. We're going to talk about splitting the hot and the cold data. That might be very interesting for you. And then we're going to talk about implementing a tag-based mode, which you might like as well. And then we're going to talk about just documenting everything. So I hope you're enjoying this series. Today, again, is day 4. And if you haven't watched day 3 and day 2 and day 1, I would encourage you to do so. And if you haven't done so, please subscribe to the channel, like this video, and let's go ahead and get right into it. The first complaint that we always get is where can I find the transformations? There is no button in the portal. When I look at the portal, I go in and I don't see a button that says transformations. I'm going to show you. So if I go into the portal here, then I go into the monitor section, data collection rules, and I look at this data collection rule. I can have multiple data collection rules, but I only have one at the moment. If I click on this data collection rule, I don't see any place where I can say transformations, how to transform the data. And in this case, the reason is because it's embedded into the JSON. So right here on the right-hand side, you see JSON view. When you click on that, you have this JSON that gives you all the information about this data collection rule. And what we're gonna do first is we're gonna go ahead and go through this to understand this data collection rule, and then we're going to find out where we can plug in the transformations and what type of transformations we're going to do. Understanding transformations. The transformations are embedded in the data collection rule, and they are pretty much executed before the ingestion takes place. So you can argue that this could be a conversation in the ingest section of the series, or you can say that it requires its own little section. I would say it's nice to have it as its own section just because there's so much information in here. And we use KQL to do the projection and to do pretty much the shaping of the data. So let's go ahead and look at the data collection rule. So the data collection rule looks like this. It has a properties section. It has a location, which is where this data collection rule, where this data collection rule exists, and it has an ID, a name, the type, the E tag, the system data, and API version. All of this is part of the data collection rule. Where we're going to focus on is this section here, properties. When we look at the properties, it has an immutable table ID. We don't touch that. That's assigned by Azure Monitor. Then there's the stream declarations, the data sources, the destinations, the data flows, and the provisioning state succeeded. Provisioning state, we're not going to touch. It just means, when it says succeeded, it just means the data collection rule is working and it's fine. We are going to be messing with these little sections here when we talk about transformation. So let's go ahead and go into the transformation section, the data sources. Let's go ahead and go back here. This right here, data sources. The data sources is pretty much where the data is coming from. In this case, we have performance counters. That's where information is coming or data that is being collected. Performance counter, the streams for inside metrics, the sampling frequency, which is 60 seconds. This was part of the data collection rule. Some of this stuff you can change in the portal, which is fine. And then it has a name, and then also we're collecting data that is coming from the Windows Event logs. In this one, it just says that the application we're monitoring, or we're capturing level 1, 2, and 3 because we set the data collection rule to warning, which means that it's all the levels up to warning. So that's pretty much what this is, and it has a name as well. So that's just the data sources. The destinations is where the data is going to go to. In this case, it says log analytics, and it just says the log analytics is where the data is going to go to. And right here it has a workspace ID. This is the log analytics workspace ID, and it has a name as well. And it's being sent to 2, but it's 2 different. It's the same log analytics workspace, but it's defined in 2 sections here. One is for the Windows and the other one is for the performance data. This is where the destination, where we're going to send the data. The data flows here. This one is just what defines where the data is going to flow to. In this case, it's Streams, Microsoft Performance, and Microsoft Events. This is the two that we're capturing. The destinations, again, this one gives it a name. And the transform KQL source. What this means is that we're not transforming anything. This is where the transformations are going to go into right here. When it's set to source, it just means that all data is being captured, and the output stream is Microsoft Perf, which is the name that is being given to this stream. So this is exactly the same, but for the event viewer or the events that are coming from the Microsoft, and it has a destination, which is the name, and it has a source. Transformations are not being executed here. Everything is source, everything is being captured. So now that we have seen this, the question is, how do we transform the data? How do we filter out the noisy rows? And the reason I wanted to explain this, the data collection rule structure, is because it's very important to understand where it's coming from. So the next thing is we're going to talk about the filtering out of noisy rows. So in other words, here, the transformation example. How we're going to drop unused objects like the paging file, the thread. Like we said, not all the data is important. So how do we do it? We pretty much set up a KQL query, and we set it up as source where the object name and logical disk, processor, and memory. And we are not going to do processor queue length. But what we're doing here is we can take this KQL code and we can inject it into the section of the data collection rule. This is going to filter the data. Again, this is dropping some of the information from the perf capture. What about Windows event logs? We can do the same thing with Windows event logs if we want to not capture certain event IDs. And what we're going to do is we're going to go ahead and filter those out, meaning that we're not going to send those, we're not going to capture those, and we're just going to leave them out. So what do? What you take is you take this source, exactly this KQL that is here, and you paste it directly into the JSON in the portal. That's one way. You can also do it from, if you have infrastructure as code, you can paste it in there as well. But this is how you filter this data specific to Windows event logs. What about Kubernetes? If you have Kubernetes, you can pretty much do the same thing in the Kubernetes section. You can say, don't capture any health probes, for example. So in this case, like readiness, all this information, you can just drop it. Where not, in other words, where not, it just means don't allow this data to be captured and sent to the log analytics workspace. Like I said, I'm going to try to make this video as interesting as possible. I know there's a lot of JSON information because unfortunately there is no other ways to do this unless you're using infrastructure as code like Terraform or some other type of scripting language that you might be using. But anyway, so I hope that you're understanding that this KQL queries are the ones that go into that transform section, and I'm going to show you in a minute on where that exists. But let's go ahead and go back to the portal and show you that. So in the portal, where you take this information is you take it in, you put it in here in the data flows right here, where you see transform KQL source. This is where you would take that code that I just showed you, like this, for example, and you would just add source and where not log entry, and you would just copy paste this information into here, and now you're filtering the data, so you're doing transformations of the data. Trimming the payload size. Why is this important? Every extra field that you're ingesting into your log analytics workspace is going to cost you, because every single byte that you're ingesting is going into the log analytics workspace and is costing you money. So using the project keyword in this case is what is telling or instructing the transformation to only send that data into the log analytics workspace. Let me show you how this works. In the portal, I'm going to go to my log analytics workspace. And I have a log analytics workspace that I've been using. So I'm going to go ahead and look at that. And I'm going to go to logs. And I'm going to go ahead and I have this table called usage. This table is one of the ones that keeps a lot of the information. I already have a query called usage get schema. What this does is just tells me what the schema of this table is. And as you can see, it has a lot of fields like tenant ID, computer, time generated, source system, start time, end time, resource URI. All of this information, if you don't filter out anything, all of this information goes into the log analytics workspace. But you may not need all of this, right? So when you don't need all this, then what we can do is we can just filter that out. And let me go ahead and show you that. So when you query this information, I'm going to go ahead and use that keyword. When you use this keyword project, it just says usage and project time generated, data type, quantity, and all this. So let's go ahead and run this query. What it's doing is it's not capturing all those fields. It's only capturing the fields that you're projecting. In other words, this is how you filter the data that is going to go into the log analytics workspace. By using this in the transformation, you are only limiting the data that is coming in to that solution there. So in other words, when you use that keyword project, it's just saying out of this whole set of data, I only want to keep this data, and that's only the information that is going to go into the log analytics workspace. So as you can see, you can save a lot of money because you're not keeping everything. And now you may say, well, what if I want to keep everything? What if I want to just keep absolutely everything? Well, that's when the next topics comes into the picture. That's when we can talk about splitting the hot and the cold data. In other words, you're going to take a subset and you're going to send it to the log analytics workspace by using transformations. And then you're also going to have a full feed that you're going to send to Blob, even though you cannot send it directly to Blob. So you would have to send it to an event hub, and then you're going to send it to Blob for cheaper archives. So in other words, you're going to keep everything in Blob, but only a subset in the log analytics workspace. How do we do that? The way we do it is in the destination section, we have to set up two destinations. One of them, we're going to give it the name of LA destination. In other words, the log analytics workspace destination. And we have to define the resource ID, the workspace resource ID. Right here is just an example, and I'm going to put this in the GitHub so you can have it as well. And then one for event hubs. So the name is going to be EH for event hubs destination, and it's going to have the information of the event hub that you have set up. You need to have that set up already ahead of time, otherwise this is not going to work. Then the next thing is, once you have your destination set up, then the next thing is you create under the data flow section, you create full feed. It's going to go to event hub, no transformations. So the code is going to be streams, Microsoft event, destination is the EH dest, in other words, the event hub destination. The transformation KQL is source, which means nothing is getting filtered out. Everything is going to the event hub, and the output stream is Microsoft event. In other words, all the events are gonna be sent there. As far as the other one, the subset for the log analytics workspace, this is with transformations. It's still in the data flow section. We create the streams, event, Microsoft event. The destination is the LA dest, the log analytics destination. The transform KQL is source, but now we're saying we're only the warning, the critical, and we're not going to be choosing events 116 and 7036. This is where you define, and then you project only the columns that you need. In other words, you don't allow all the columns to go into the Log Analytics workspace. You only select these columns, and these are the ones that you are going to save in the Log Analytics workspace. And the output stream is Microsoft Event. So this is pretty much how it works. Event Hub is going to go to Blob. In the Event Hub blade, you can set up a capture, and you're going to enable, and you're going to set it up as a storage account. So when the data comes in into the Event Hub, it's going to go in and end up in the storage account at this point. You can choose the format. You can set up Avro or Parquet, and you can set up an interval as well. And all the logs are written automatically to Blob at that point. Again, this is another strategy that you can use. I showed you in the previous video yesterday how you can set up the diagnostic settings when you have two different entries, one for the Log Analytics workspace, one for the storage account. Unfortunately, in this case with the logs, it doesn't allow you to do it. So this is a great method of being able to save a subset in Azure Log Analytics workspace and the rest in storage. So now what we're going to do is we're going to get into the conversation about implementing tag-based mode. The tag-based mode is you set up two different data collection rules. One is going to have transformations. You can set it up whichever way you want. And then the other data collection rule is going to be one where it's going to just have specific fields. So if, for example, you're trying to troubleshoot something, then you can set it up where when you set up a tag, when you turn on a tag for a VM, for example, then you're going to set up a policy, and the policy, when the policy sees that the tag changed, is going to assign a different data collection rule to this VM, which means that you're going to start capturing everything on that VM. It's almost like setting up a VM in debug mode, but you're going to do this just by changing the tag. When you change the tag, it applies a different data collection rule. So this is pretty much what we would do. You switch the tag and you change it to verbose for troubleshooting. This saves a lot of money because you're not capturing everything unless you're in that verbose mode and you set it up using a policy. And then the last thing that we want to talk about is standardize and reuse. Document all approved KQL transformation snippets. You want to make sure that you document it because you're not going to remember everything, right? So it's better to document because you do have to go into the JSON and you do have to take the snippets and put them in there under that transform KQL section. And if you don't know where they are, you don't know what you did, then it's going to be difficult to find them later. Okay, and we're going to leave it at this point. I hope you enjoyed this video. I hope you learned something. And if I missed something, please leave it in the comment section down below. And if there's something that you would like to see, please also leave it in the comment section down below. And until next time, take care.